Okay, here we are at the last podcast of Unit 1 where we're talking about and reviewing a few ideas about density, because you've probably heard that word before, and we really are just covering that last little part of page 17. It's really not that much, not that bad. But let's first start with the definition of density. Technically, a very technical definition is a ratio of mass per unit volume. Okay, but what does that mean? What is it telling us about a substance? So this is my preferred definition. Density measures how tightly packed our matter is. So we've got the mass in there, and it's measuring how much matter we have, and then per unit volume is telling us how much space we're letting that matter take up. And so I really do like the second one. It's talking about the same things, but it uses a little bit more relatable words. And if you think about the solid, liquid, and gas version of a substance like gold, I think is going to be the first substance we talk about their density. The only difference between solid gold and liquid gold is the fact that those molecules are farther apart and moving a little bit more as a liquid. So in general, the solid form of a substance is more dense than the liquid, and the liquid is more dense than the gas. And they spread out and they're less compact. Even if we have the same amount of matter and it's the exact same atoms there, they haven't chemically changed, they're just separating out. That's going to make them less dense. So we're going to be calculating some densities and using this formula for density. So let's get that written down, and then let's record what each of these letters is. M, probably not super surprising, is that mass value. And make sure that you write down grams next to it, because you're not always going to see a problem tell you the mass is 5 grams. It might just say the sample is 5 grams. It doesn't have the word mass anywhere around it, but you should be able to see those units of grams and figure out that they are talking about mass and that it should go there in our equation. The V stands for volume. We have a choice with our units for volume, either milliliters or centimeters cubed. And as I had mentioned in a previous podcast, 1 milliliter is equal to 1 centimeter cube. If we had a centimeter cube, meaning a cube with 1 centimeter sides on every side, then that, when we fill that with water, that would be 1 milliliter of water, or any other substance. So doesn't matter which units are on it. It might change based on the problem. My preference is milliliters, just because they look a little less scary. And then, of course, the D stands for density. And these units might look complicated, but if you notice, it's almost like they're their own little formula. In order to find density, we're taking our grams divided by our milliliters, or centimeters cubed. And those units just combine together the same way that the numbers we put into this are going to combine together. Mass divided by volume, grams divided by milliliters, or centimeters cubed, if that's your jam. So these look complicated, but it's really just combining together these separately measured units. Now, this equation is useful if we want to calculate density, but really what I think the real power of density is that we can use it in dimensional analysis problems as a unit equation in order to be able to convert between mass and volume. And let's do that here in this first problem. Don't worry if you're not a dimensional analysis person. I know that sometimes people's brains just stop working on tests and quizzes, and dimensional analysis just doesn't make sense, just like I tried to just say that some weird random way. But I will show you the algebra version of this first question, but I think the dimensional analysis way is easier. And the first step is going to be to take that density of gold that they're giving us, 19.3 grams per milliliter is how I could read out those units there. And what that's telling us about the gold is that if I have 19.3 grams of gold, because that's 19.3 grams per milliliter, that's going to be equal to 1 milliliter of gold. I almost kind of envision this as pulling apart the two separate sides of that term. And we've got the 19.3 grams goes on one side of the equal sign, and then this slash milliliters almost turns into 1 milliliter there. So you're just pulling apart that density and putting an equal sign between those two units there, here. So this is now in its equation form, and we're going to be able to use this in doing some dimensional analysis. So the rest of that question, which actually gives us our given, asks us what is the volume of a 15.5 gram sample of this gold. So 15.5 grams is our given, and we're trying to turn this into volume, so milliliters or centimeters cubed. Now, if I'm looking at this equation and using this as my conversion factor, then because I have grams up on top with my given here, I know that the grams part of that equation is going to have to go on the bottom of that next bracket. That's that diagonal rule still at work. And then if I just put 19.3 grams on the bottom, that means that 1 milliliter is going to have to fill in the top. And that's it. That's as much as we need. And we can double check our grams have canceled. We've got milliliters, which are units for volume. So we've set this up correctly, and all that's left to do is plug this in to our calculator, and the answer I'm getting out is 0.8031, and there might be some more numbers there, but I'm actually going to stop at the 3 because that is 3 significant figures, just like my given was. I'm just going to make sure to add the milliliters units that we ended up with here at the end up on top of our dimensional analysis. So I really think that that's probably the easiest way to work out this problem. But like I promised, I'm going to do it with some algebra as well. You will have to remember the equation if you're going to use the algebra method. But if you remember that density is love, then maybe you don't love it so much. You can put a line through the middle of it, and that will remind you that we are putting our mass over our volume in our density equation. You can kind of see the M and the V here. So all we're going to do is plug in to this equation. I'm going to neaten it up a little bit. So here again, it gives us our density. It says that's 19.3. So I'm just going to put that in the equation spot in where the density is. And then our mass that we're given is those 15.5 grams. And just like I mentioned, it doesn't say that it's mass. It just tells us that it's grams. And so here you have to remember, which one is which and where to put it. You can't put that down on the bottom with the volume. But hopefully, since it was asking for volume, you'd know that wasn't the volume. So I've just taken that equation and plugged in the numbers that I know into those two spaces. And now I need to use some algebra in order to rearrange and solve. My goal with algebra is always to get V equals to something. So I want to get V all on its own side. And actually what's going to get in my way, first off, is that V is in the denominator of this fraction. So even if I got rid of all the other numbers, I'd be left with 1 over V as my answer. And that's not what I want. So first I'm going to do some algebra because we're dividing by V here. The opposite of dividing by V is multiplying by V. So that will cancel out the V on this side, make that go away. And then what I'm left with over on this side, because I have to do the same thing to both sides if I want to keep things equal, then is V times 19.3 is equal to 15.5. And I still don't have V all by itself, but now I can clearly see a way to get it by itself. Instead of times 19.3, we do the opposite and we divide by 19.3 on both sides, of course. Then that's going to cancel these out here, and we will be left with V all on its own. And this is telling us that all we need to do to find our V is 15.5 divided by 19.3. And this is the exact same math that we did in the last problem. I just was able to get there by arranging my units. And so the math is the same, the answer is the same, the rounding and sig figs process is the same. We're still looking at 3 sig figs here. The only difference is whether you like rearranging equations to solve for that unknown, or whether you'd rather use that density as an equation in order to convert using dimensional analysis. So this is a lot messier to my taste, but it's up to you what you prefer. You can do it either way. Now, these next couple of problems, I'm just going to work out the dimensional analysis way. If you'd prefer to work it the algebra way because you're more confident with that, go for it. That's full credit as long as I see some kind of work supporting your answer. So this question is asking us to find the mass of 32.5 milliliters of sulfuric acid if I know its density is 1.83 grams per milliliter. And as soon as I see that there, I'm going to go ahead and turn that 1.83 grams per milliliter. This is now in its equation form, ready for me to use in that dimensional analysis. And I can just start with my given, the 32.5 milliliters as my given. If milliliters are on top, this time I'm putting the milliliters part of my density equation on the bottom. Gotta follow that diagonal rule, and that means that our 1.83 is filling in the top. Just double checking, my milliliters and milliliters would cancel out. I'd be left with grams, and those are the units for mass. So this looks like I've done everything I need to. Ready to just multiply these two numbers together and divide by 1 as well. And the number my calculator is giving me is 59.475. Looking back, I want to keep 3 sig figs, so I want to keep 59.4, but the 7 is going to round my 4 up. So my final correct answer is 59.5 grams. And even if you do it with algebra, you should get this same answer. If you're not, let me know. I'll help you. Let's do one more problem here, and this one is asking us for density. And honestly, if something asks for density, the easiest way to do it is just use the density equation, because that's what it's designed to do, help you find density. So our mass in this situation are grams, 3682, over our volume, 53.4. And if we do those grams divided by those milliliters, then we are going to get 68.951 out. I only want to keep 3 significant figures. I know there were more here, but our least number of significant figures we started was 3. And the pain here is that the 5 is going to round that 9 up. So that's going to become a 0, and that means that's rounding up this. So 69.0 is going to be our density, and because we were taking grams and dividing them by milliliters, I'm going to put grams / milliliters as my units on that. So definitely a lot easier than trying to force some dimensional analysis, something to happen here. If it's asking for density, just use the equation. There's no rearranging to do. You just plug in the numbers and divide. So in this next question, it's another straightforward density question, but it gives you some science data here. So we have a mass, and if I know I'm keying in on what is the density of the metal, I know I'm just going to be finding my grams, 147, and dividing by my volume. But I have a lot of volume numbers given to me here, so I'm going to read through this question a little more carefully than last time. Says that we're putting a metal in a graduated cylinder and the water level rises from 20 milliliters to 41 milliliters. So it hasn't actually told us the volume of our object. What it's telling me is where it started before I put my object in the water and where it ended up after. This is called water displacement, and if we subtract these two numbers, that will tell us what volume, how much space our object took up. So 41 minus 20 is 21. So just like the last problem to find our density, we just have to divide. My calculator is telling me this answer is 7, but if I pay attention to my original sig figs, I should write that as 7.0 grams per milliliters. And that is my final answer. Now, the last question on here might seem like a whole lot and a lot of complicated stuff, especially since it's talking about, oh, go find the density of water to be able to help with this. Well, my hint is that density of water is 1 gram per milliliter. That's nice and standardized. Density is 1. And for something to float, it at least has to have the same density as the water or whatever it's displacing and pushing out of the way. If it's more dense than water, it sinks. If it's less dense, it always floats. If it's equal, it should float. But that's why it's talking about finding the minimum volume, because hopefully we'll make it less dense than this. We'll make it bigger to make sure that this boat is going to be floating. But if we are starting with 1,300 gram boat, and I want to make sure that the volume of that boat is going to be equal to the amount of water it's pushing out of the way so that it will float, then I just need to make sure that the boat has a density of 1 gram per milliliter as well. So I'm going to put the 1 gram on bottom, 1 milliliter on top, and the math here, you might need to grab a calculator for. Sorry, just joking. Because we're multiplying by 1 and dividing by 1, then our answer is actually 1,300, but our units have changed. That's what our dimensional analysis did for us, is it got rid of those grams, and now this is milliliters. So as long as my boat takes up at least 1,300 milliliters worth of space, then it will float. And hopefully we make it take up a little bit more space to make it a little less dense so that we can put some little stick figurines or something in there. But that's our density used as a conversion or just calculating it using our equation. Hopefully that wasn't that bad. That is officially the last podcast you got to listen to until next unit at least. Have a good one, everyone.